Today we're looking at notes 5-1, transform quadratic functions. So this function, quadratic, parent function, should be very familiar to you because we've talked about it in Algebra 1. So the coordinates that you need to memorize for this parent function are as follows. You've got -2, -1, 0, 1, and 2 for x. So if I plug in -2 for x, -2 squared is 4, -1 in for x, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So these are the 5 ordered pairs, 1, 2, 3, 4, that you need to have memorized, as well as plot for each quadratic that you graph. Okay. So now that I've plotted all 5 of those, I'm going to draw my curves through the dots, through the points. So that's what it looks like, okay? A couple of quick characteristics that you should already know anyway are the point here is the vertex. So for the parent function, the vertex is the coordinate 0, 0. Also, very similar to absolute value. The axis of symmetry cuts it right down the middle. It's symmetrical about this line, and that line is always going to go through the vertex, just like absolute value. So my axis of symmetry is the line x equals 0. It will always be the x coordinate of the vertex. So x equals 0 in this case. All right, and as you probably already know, one more thing, domain, just like absolute value, it's going to span all the way left, all the way right forever. So our domain of this guy is going to be all real numbers, you guessed it. And just like absolute value, since our vertex is here at the origin, and it doesn't go below that, my range is going to be y is everything greater than or equal to 0. Okay, so my domain is going to be x such that x is all real numbers. Or for interval notation, you know you could do the negative infinity to positive infinity. And the range is going to be y such that y is greater than or equal to 0. And if you wanted to write it in interval notation, you know it would go from 0 to positive infinity. The 0 would have a bracket and the infinity would have a parentheses. Okay, so let's talk, now that we know a little bit about quadratic parent function, let's talk about some transformations. This again should be very familiar because we've done it in Algebra 1 and it's just like absolute value. It's just a different parent function. So this -1 is on the outside. It's like a tail. It's after the x squared. So that is going to deal with up and down movement, anything after the x squared. So on this one, since it's minus, it is going to shift my origin down 1. So my new origin is now down 1. I've plotted that. Okay, and from there, I'm going to plot my original x and y values. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So you can see I've just taken that quadratic parent function, I've shifted it down 1. Okay, so let me go ahead and write down 1. That's what that -1 does. Okay, moving right along, here you see this -1 is inside the parentheses, so it's with the x. Remember, addition and subtraction inside with the x is going to account for your left and right movement. Horizontal, because it's inside with x, and x runs horizontally. The x-axis runs horizontally. So this one here, remember, inside the parentheses or absolute value bars, depending upon which parent function you're dealing with, is opposite of intuition. So you would think this -1 would be left 1, but it is actually right 1. Okay, so now I'm going to put my new origin and I'm going to plot my original x and y values. So -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So there's that guy shifted right 1. Okay, so now let's look at this. There's multiplication on the outside, 2 times x squared. So when I have multiplication outside, in front, directly in front, that is going to stretch if the number is bigger than 1, and 2 is certainly bigger than 1. So this is a vertical stretch by 2. So for example, if this was 1/2 instead of 2, it would be a vertical compress or a shrink. You can see it called different things by 1/2. But since this number is larger than 1, we call that a stretch. And so these are the type, the ones with a number out in front, that you need to do the table with the 3 columns. So we know our original x values are as follows. Our original y values are as follows. And then what we need to do is we need to take those y values and multiply them by 2. So that would be 8, 2, 0, 2, 8. So now I'm not going to plot the original y values, I'm going to plot my new ones. And this origin has not shifted at all because I don't have a plus or a minus inside or outside here. So my origin stays at the actual origin, and it's going to go -2, 8, -1, 2, then 0, 0, and then it looks like that. So you can definitely tell if you're looking vertically, this graph has been stretched, okay? It's been pulled, it's skinnier. So let's talk the negative out in front. You're familiar with this. The negative out in front makes my graph reflect over the x-axis. Okay, and again, on this type, you're also going to have to do the double table. And I'm sure you'll get to the point where you don't need the table, or maybe you don't already need it now because you know exactly what's going to happen. But for sake of this is our first time doing it with this graph, I'm going to go ahead and draw the table. So I'm taking all of my y values and multiplying them by -1. So this is going to be -4, -1, 0, -1, -4. So I'm no longer concerned with the original. Has my origin shifted? No. The only thing that's happened is the reflect. So I'm plotting all this stuff from the original origin. So -2, -4, -1, -1, 0, 0, so on and so forth. So as you can see, my graph from the parent function to this has reflected over the x-axis. All right, so let's combine everything we've learned. So on this graph, we've got a couple of things. We've got the reflect over the x-axis. We've got, okay, +2 on the inside. That's either left or right. It is actually left 2. And the +1 on the outside is going to shift it up 1. Okay, so the first thing I need to do is shift my origin. So my origin shifts left 1, 2, up 1. So I'll put my plus sign there. That's my new origin. Okay, and then from there, I know that my graph is going to reflect over x. So you would do the table. Since I already did it over here, I'm just going to kind of reuse this. I know because the negative out in front, I would multiply my y values by -1, which I've already done here. So I'm just going to go ahead and steal this table and use it, and I'm going to plot these points from my new origin. So -2, -1, 2, 3, 4. There we go. And you know it's symmetric, so you know where your points on the other half are going to be. All right, and then there's my new graph. So, working backwards, here, write a quadratic function matching the description. The parent function is stretched vertically by a factor of 8, translated, so stretch by 8, translated 7 units down and 3 units right, and it's been reflected over x. So kind of piecing this together, the first thing I know, the reflect over x means a negative on the outside, on the very, very front. The stretched by 8, that is on the outside in the very, very front. And then we're going to have something like this. Kind of those are my bones. What goes in here is either left or right movement, so that's this guy. So 3 units right means not plus 3, but minus 3. And then last but not least, 7 units down, that's going to be a minus 7 tacked on the end there. So that's your equation going backwards from the words. Okay, so what I want you to do is come to class prepared with these 2 answers, ready to check in class to make sure you're getting the hang of this.